Hello, and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and serving the over 100,000 computing professionals and students who are ACM members. That would be you. My name is Andrew Coe. I'm an associate professor at the University of Washington Information School and an adjunct associate professor in computer science and engineering. Just so that you know a bit about me, my research areas are human-computer interaction, computing education, and software engineering. And I tend to focus a lot on software defects and how people and society discovers, diagnoses, repairs, and recovers from defects, spanning everyone from people who use software to the people who develop software. I'm also co-founder of a startup called AnswerDash, a SaaS company offering instant answers on websites using a selection-based search technology that I invented in my lab. You can see a lot more about me in the bio window on the left side of your screen. So I'll be our moderator today. A couple of things before we get started. For those of you who might be unfamiliar with ACM or what it has to offer, ACM recognizes the role of computing in driving the innovations to sustain competitiveness in a global environment. You can see a lot more of the highlights and resources that ACM has on your screen. You'll be able to see these later as well. And then, again, a few housekeeping items that you might not have seen if you weren't logged in earlier. I want to quickly mention a few things on the slide in front of you. The slides are going to automatically advance by our speaker, Paul, who I'll introduce in a second. So on the bottom panel, you can find a number of other widgets and resources. If you ever have problems with the presentation slides, go ahead and just refresh your browser. That's an F5 key in Windows or a Command R if you're on a Mac. And that should resolve any of the issues. We don't tend to see any of those issues. To control volume, you can adjust the master volume on your computer. At the end of the presentation, they'll also have time for questions. So you can find the Q&A part, the widget in your screen, and type your question in there, and I'll be triaging those and selecting some to present to Paul so that Paul can answer them at the end of his talk. This session is also being recorded and will be archived, so you'll be able to receive an automatic email notification when it's available, and check learning.acm.org in a few days for updates. Lastly, you can use the Facebook and Twitter widgets on the bottom panel to share the presentation link with your friends, as well as tweet comments and questions using the hashtag ACM Learning. We'll be watching for your tweets, and so if you want to send questions that way as well, you can do that. Now, today's presentation is by Paul Lee, and it's on what makes a great software engineer. In case you don't know, Paul is actually my PhD student, but Paul is also a senior data scientist at Microsoft's Windows and Devices group. So he's a PhD student with me part-time. He's been a researcher and a practitioner of software engineering for over a decade, with experiences at Avaya, ABB, IBM, and Microsoft. He got his bachelor's degree in mathematics from the University of Virginia in 2001 and a master's in software engineering from Carnegie Mellon in 2007. With that, Paul, we look forward to your presentation today, and the rest of this is yours.
Thank you very much, Andy. So today, I'm going to be telling you guys something about great software engineers. That is, people who develop code to be used in earnest by others. Now, whenever I start one of these talks, I like to use a quote from a partner dev manager in Windows that I used to work for. Now, this is somebody who used to manage the Windows kernel team. And he used to tell me, Paul, you know what? At the end of the day, in order to make changes to software, it still takes a developer a button to see somewhere to type SD commit. And this quote really underlies the understanding that good engineers are essential to the creation of good software. That we can have all the tools, processes, and technologies that we like, but at the end of the day, it still takes a person, a software engineer, a button to see somewhere to decide what to build and how to build it. And therefore, it is essential that we know what attributes entail software engineering expertise, and why those attributes are essential for the creation of software. This knowledge will be important for educators like the ones at the University of Washington who want this knowledge so they can train great software engineers. This knowledge will be important for employers like Microsoft who want this knowledge so they can hire and retain great software engineers. And young engineers want the information so they can know what it takes to become great. So when I started on this investigation, I looked around at what is already known. And what I found is that although much of the knowledge of what we have is directionally sound, it was very much incomplete, indirect, or abstract. For example, much of the software engineering literature focuses on productivity. That is, finishing more tasks, finishing them faster, or finishing them with fewer mistakes. Then many of the research on processes or tools really focus on these outcomes, implying that these are the key essential attributes of great software engineers. But we broaden our perspective and look at the research that looked at young engineers going into new teams and becoming successful. What we found there is that research like Kelly, Beagle and Simon, and Hurwitz and Girdell thinks that collaborating effectively in teams and being able to make meaningful contributions in a quick amount of time are what is important. And furthermore, when we actually looked at the research, for example, by Latoza and co., when they embedded themselves into actual software engineering teams and observed what software engineers do on a daily basis, they found that in addition to writing and editing code, that the engineers communicate with each other, that they go around to each other's offices, acquires each other's understanding and feedback, and together make good decisions about what to do. Now, beyond just technical knowledge, now the ACM curriculum also specifies other things like design, modeling and analysis, verification and validation, project management, all these peripheral technical skills in addition to coding that makes a great software engineer. And finally, there are reports from industry, from places like Google, that imply that being open-minded and having a desire to learn are much more predictive of the long-term success of an engineer. So taken all together, what we see the gap here is that there is incomplete, indirect, and abstract knowledge about what it takes to be a great software engineer. So unlike prior studies, which only imply what is important, like the ones about productivity, we want to look at software engineering team engineer expertise directly. And in addition to just a few attributes here and there covering one area or the other, what we want to examine is holistically about all the attributes to have a more complete understanding of what software engineering expertise entails. Now, another issue is the fact that some of these knowledge that we have are backed by data, but others are simply claims that are not really substantiated. That we want a more rigorous, a more deeper, have more confidence in the understanding that we have. And finally, and most importantly, we want to have clear definitions and clear understandings. We want to know exactly what these terms mean. No more vague terms like great communicators. We want to be able to you to be able to explain to other people what these attributes are and have a clear understanding of why these attributes are important so that educators, employers, and young software engineers can use this understanding to reason about what it takes to become great. So the way that we did this is that we went to systematically examine attributes of software engineering expertise directly from expert software engineers. Now, we saw this understanding for expert software engineers at Microsoft. Now, to be clear, part of this reason is because I work at Microsoft, so I have access to these engineers. But also, as I started to research more, I found that in addition to being one of the largest, most successful software engineering organizations, Microsoft is incredibly diverse, covering a wide range of technologies and software engineering contexts that can offer a holistic perspective on the area. From consumer software in places like Windows and Xbox and phone, to enterprise software with servers and tools, Windows Server, and corporate dev and Dynamics, to even online platforms like Bing and App Platform. Now, furthermore, Microsoft has a great number of talented and experienced software engineers. We scoped our research to people who have 3+ years of software engineering experience, people who are at the software engineering level 2 and above. So they've been affirmed through promotions as somebody who has a level of expertise. And then in addition, we specifically targeted very experienced software engineers, people with 15+ years of experience, with titles like Technical Fellow, Architect, Partner Dev Manager. These were people that were leading entire engineering organizations who are thought leaders in their particular area and who have seen through their many years great software engineering and great software engineers. The particular approach that we took is a qualitative approach, that we used structured interviews. In all, we interviewed 59 plus software engineers, had 60 plus hours of interviews, and over 380,000 plus of transcripts. Now, I can tell you that interview studies, when done correctly and with rigor, can really provide deep and rich understanding of the hows and the whys that simple counts and ratings simply cannot provide. So in our hour-long interviews, we got into deeply their experience based on actual engineers. So we asked them what were the attributes of the great engineers that they've worked with. And furthermore, we were able to drill in and ask for significantly more details. We asked why each one of the attributes I mentioned were important in real-world settings. We asked for specific settings and a past example where those things actually turned up. So that we also then transcribed all the interviews, read them repeatedly in detail, iteratively refining our definitions and our explanations of why they're important. Furthermore, even went beyond and validated this set of understandings and definitions independently through a senior software engineer. Taken together as a whole from our interviews, we were able to discern 53 attributes of software expertise. And what you note is these are much more extensive and nuanced than we have seen in previous work. Now, there's no need to try to read them all individually now. I'll be going over them more in detail later. So overall, what we see is that attributes of software expertise entail attributes that are both internal to the software engineer, entailing their personalities and their ability to make good decisions, and also entails external attributes of their interactions with teammates and of the code that they produce. So the first area that we are going to cover is internal personality traits of the engineer. And as the principal Dev Lee said, that is something that cannot be taught. They just have an inner desire to succeed. And I don't know why. It's not necessarily for the money. It's not necessarily for the recognition. It's just that whatever it is they do, they want to do it extremely well. I've seen a lot of smart people that have none of these characteristics. Now, this engineer went on to describe young engineers that he has hired, ones that seem very similar in terms of their intelligence and technical competence. And yet, some move on to be great engineers and others languish. And he really thought that some of these personality traits are the cause. That these concern who these software engineers were as people. These were likely intrinsic to the engineers, formed through their upbringing, and were difficult, if not impossible, as said by many, to change. Now, the two particular attributes that we're going to examine in detail are continuously improving and open-minded. Now, these attributes are particularly interesting. These were based on about how the software engineers talked about them, how many talked about it, and the reasons for their importance, that we believe these may be very important, or can give some very interesting perspective, are the current state of software engineering today. The first attribute we look at is continuously improving. And as the SDE2 says, computing technology compared to every other science or technology, pretty young. Every year there's some new technology, new ideas. And if you are only satisfied with the things that you already learned, you'll probably find out in a few years you're out of date. Good software engineers, they keep investigating, they keep investing. So this attribute was about being not satisfied with the status quo, and constantly looking to improve themselves, their products, or their surroundings. And this really captures the understanding that you need to continuously learn in order to become and to continue being great. Now, the obvious thing here is that young engineers did not start out being great engineers, but they need to learn and improve in order to achieve greatness. But the other part, the more interesting part potentially, is that informants felt that the software engineering field was rapidly changing and evolving. That unless engineers kept learning, they will not become great. And furthermore, they will not continue to be great software engineers. That this notion of running up an infinite escalator was prevalent among our informants. The next attribute we look at is being open-minded. As the senior SDE says, no matter how much you know, the software industry is so large. There's so many other areas that if a person has something to say that hasn't occurred to me, I'll stop everything and say, okay, explain this. What did you see that I didn't see? But this was about being willing to judiciously let new information change how you think, not taking your current understanding as gospel. And this captures the underlying sentiment that you need to avoid thinking that you know everything. So, though many informants talked about positive attributes of engineers that they admired and liked, many of them also frequently mentioned and lamented about deleterious attributes of bad engineers. So while we have stated many of these attributes in the positive, part of being a great software engineer was about avoiding some of these bad attributes. And in this case, even though we talk about open-minded, it's really about avoiding the not invented here syndrome, about thinking that you know everything, dismissing the ideas of others. Informants felt that outcomes in the software engineering field, things like user reactions or commercial success, were very difficult to predict. Therefore, engineers had to be open to changing their perspective, to changing their outlook on things in order to be great. And the other interesting thing is that they understood that the software engineering today and the software product they produce can be very large, very complex, and constantly changing. That if others have good ideas, have novel insights, that engineers need to be open to those ideas and to incorporate them into their understanding. And this gets to our first takeaway, that results indicate that the ability to learn is likely more important than any individual technical skill. Now, informants, even ones in the same division, rarely mention the same technology area, such as architecture, being essential. Rather, most of our informants stress needing the ability and the capability to learn new skills and abilities, and the attributes associated with it, things like being open-minded, as being critical to being a great engineer. The next area that we're going to look into is the ability to make good decisions. And as a technical fellow, the most senior person we were able to talk to in our interview says, how do we make what I call robust decisions? What's a decision that we can make that, depending on this range of potential outcomes, which we can't even foresee, if we can make a decision that is viable, whether A or B happens, then we don't have to fight about A or B right now. Now, informants felt that great engineers needed to be able to make good decisions. That is, understanding what the current situation is, recognizing when a decision needs to be made, understanding where are the available decision alternatives, knowing their probabilistic outcomes, both positive and negative, as well as the value of those outcomes. Now, this entailed attributes associated with having knowledge in various important areas, and being able to build and maintain good decision models, and having the mental capacity and ability to adroitly reason about their decisions at multiple levels of abstraction. So the two attributes that we're going to look at in detail are updating decision-making knowledge and being able to mentally handle complexity. So the first attribute we want to talk about is updating decision-making knowledge. And as a technical fellow wanted to say, sometimes what used to be a second or third order effect comes to dominate. So way back in the day, if you wanted to performance optimize something, you counted instructions. But as processors got faster and faster, but memory references didn't, there became a day when it made more sense to count memory references than it did to count instructions. Now, unless you are conscious of when those things will intersect, you'll be on the wrong side of history and be frustrated. So this attribute was about continuously updating the mental decision model at all levels of abstraction, ranging from technical details to industry trends, and to be able to explicitly evaluate how those changes affect their decision making. And this underlies understanding that this is needed in order to continue to make optimal engineering choices. The great engineers understood that new options became available every single day. Now, what might have been impossible using yesterday's technology may now be possible. And you needed that in order to advance your software product to a new area or to achieve new things. And the next thing was that the computing context changed, that the expected outcome of your previous choices may now change. That if you continue to optimize, for example, instructions instead of memory references, that your decisions may not be optimized in the future. That you need to understand how the context changed in order to update your decision making constantly. The second attribute is about being mentally capable of handling complexity. As the senior SE says, to solve problems, great engineers have to have the ability to connect things. Because you are always debugging layers and stacks of code. This layer talks about some other layer in the horizontal, and you need to solve the problem. You have no idea what's going on. This captures the underlying understanding that you need to be able to grasp and reason about complex, intertwining ideas with agility. And the underlying understanding that decisions in practice are often very complicated. That software is sometimes built upon many other layers of technologies. Many APIs and libraries that you have to call in order to make your product. That in fact, your software may need to interact with many other components, whether it be horizontal or up and down. That there are myriad constraints and considerations you need to take into account when you're actually deciding on something. That in real world decisions, you need to be able to handle all these complexities in order to come out at a good decision. And this gets to our takeaway number 2. That making good decisions, though it is rarely discussed in the software engineering literature today, it is in fact critical to being a great software engineer. And informants felt there are usually myriad options for what to do and how to do it, but not all of them are good. And as engineers grew in their careers, as they became leaders and experts, they're increasingly tasked with making decisions in increasingly more complex and more ambiguous situations, with often significant ramifications for not just themselves, but the success of their organizations. The next area we're going to look at is interacting with teammates. And as the senior SCE says, the way this great engineer just kind of touches people, just dissolves the conflict right there. That magic to make everybody respect him, that's fun magic that I think not everyone possesses. Now, informants felt that great engineers were at minimum expected to be able to play well with others. But more beyond that, they were expected to positively impact their teammates. And for many engineers, as they grew in seniority and skill, this was an important part of their job as leaders or managers. Now, the attributes in the area focus around being a reasonable person, being a good leader, but also communicating effectively and building trust. And those two areas are where we're going to drill in a little bit deeper. We're going to look at 2 attributes that are essential to building trust and being able to communicate effectively. We're going to see exactly what they mean and how they affect engineering outcomes, because these 2 areas, we feel, are often mentioned in the literature, but often with a little contextual understanding and clear definitions. The first attribute we look at is honest. And as a principal dev manager says, having somebody else trusting you. It's about, I know this person always speaks the truth. And the result of that, when they say something is good, I will totally believe them, because they're not trying to kind of misrepresent something or make them look better. And this was about providing credible information that others can then act on. And this was what underlined trust. Then this was critical for trust. What we found here was that this was clearly one of the most deleterious attributes that engineers did not like. That they did not want to be shifting blame around. They wanted to be solving problems. And having a lack of honesty, both because you don't know if the other person is telling you something that is not true, or that they're misleading you in some area. Now, this is one of the things that really paralyzes the organization, the team, and even individuals from making forward progress. That if the team really was having too many engineers that were dishonest, it was an important reason for actually an organization leaving a team. The second attribute was about creating shared understanding. As the principal Dev Lee says, our area where things are inherently difficult to talk about. We have to go to business partners or with a customer. They think about things in much different terms. You kind of have to switch gears. Be able to tell them why you should care about it, and here's how you should think about it. And so this attribute was about being able to adjust one's message to be able to effectively mold another person's understanding of a situation. And this was seen as essential to being able to communicate effectively. There was an understanding that even though everybody speaks English, not everybody speaks the same language. That engineers, especially as they become experts and leaders in the areas, often have to talk to other people, whether it be engineers in other divisions and areas, or experts that are non-engineers, or even regular customers. So adjusting one's language so the other person can incorporate your information into their understanding is seen as essential. The other area that's particularly interesting here is about the ability to be able to effectively marshal resources. That we saw many engineers talk about being able to get everybody onto the same page. Well, large software engineering efforts require the efforts of many engineers. That being able to communicate a shared understanding that everybody can go towards the same objective was seen as key to having good engineering outcomes. And this really gets to our third takeaway from this particular area. That software engineering is a social technical field. That is how the software engineering is conducted, whether it be relative to management, your subordinates, your teammates, or your partners are all critical to the success. That software engineering is a social technical undertaking and not just a technical one. The next area we're going to look at is engineering the software product. And as the senior SDE says, it's about the style. This guy always had an idea that it was all very clean, very concise. By just looking at it, you can say, okay, this guy, he knew what he was doing. There's no extra stuff. Everything is minimally necessary and sufficient, as it should be. It was well thought out off screen. What we saw was that software engineers were like artists, admiring the masterpiece of other artists. That our informants, many of whom were great engineers themselves, saw beauty in the software product and designs of the engineers around them. We're going to be talking about two attributes in detail: paying attention to coding details and elegant. Pays attention to coding details, as one principal SD puts it, is about this code is performance critical, compatibility sensitive, and is used in a huge variety of contexts. If a developer fails to handle an error, some customer will hit it and will likely need to issue a hotfix. If a customer implements an inefficient algorithm, n squared is not okay. Consumes memory excessively in some environment is not okay. This was about producing quality code that considers error handling, memory consumption, performance, security, and style. Basically, what it boils down to is you have to get the basics right in order to be respected by your peers. What we saw here was that greatness is really a peer-bestowed title. That unless you were able to get the basics right, that engineers would not respect you. The next attribute was about elegant. And as the senior SDE says, never complicate anything. When you simplify things, it becomes easier for you to maintain. Going forward for customers, you get a lesser number of issues reported by them. And so elegant was about being able to produce simple and intuitive designs, and none another person or even yourself on a later date could easily understand. And this captures the understanding that avoiding complexity, even though everybody knows is necessary, can be very difficult. That informants generally understood that avoiding complexity was necessary in software engineering. Complex situations increase the likelihood of bugs, increase the cost of maintaining code if it was fixable at all. That evolving software can be even more costly when the design was very brittle to change. Yet, however, everybody knew that sometimes complexity was inevitable, that you're inheriting code from another person. There was a large amount of engineering debt, and that just simply at Microsoft, you just had many of the softwares need to build upon many layers of technologies, interact with many things. The complexity was unavoidable. And therefore, in order for a software engineer to be able to produce elegant designs, things that were simple and yet effectively solved the problem and met all the requirements was simply revered. And so the understanding from this area and the takeaway is that delivering code is often insufficient, that complex contextual considerations are abound, that the simple examples that we see at school where you can fudge around with the code and simply submit it to an online submitter and get it passed is not sufficient. That in the real world engineering software, with attributes of elegant, creative, and long-term, software engineers need to account for complex and technical considerations when designing and implementing their software. So far I've talked to you about 8 attributes in the 4 different areas of software engineering expertise. And we definitely encourage you to read more about it in our paper, which we have linked on here. That there are many other interesting and important attributes that entails what it takes for a person to be a great software engineer. And if you go on and read this particular paper, we really believe that this can help you as a leader of engineers. That first and foremost, I feel they can help you make better hiring decisions. You know, at the end of the day, instead of sitting in offices and talking with each other about these soft skills, about whether they're a good fit for the team, you can actually structure those conversations around specific attributes and have a shared understanding with other hiring managers about why it is that person will be good for your team. And furthermore, many of these attributes are directly associated with good leadership, that senior leaders and expert engineers can really study upon these in order to better be able to lead their teams. Because one of the most important things that we saw is that leaders for many of these attributes are the ones that really cultivate those things in their organizations. That as a leader, you need to be able to avoid the leader's attributes, stamp them out, and to encourage good attributes, promoting them, so that you can better hire and retain great software engineers. And next, if you're a young software engineer just starting out, we really do feel that these are some really great areas for you to target improvements. And even beyond that, we feel that these are important for you to be able to target your fit with an organization. But we saw in our interviews that various teams emphasize different attributes differently, that some were more leaning towards one set of attributes than others. Therefore, it's important to figure out what set of attributes that you particularly want to achieve and you particularly feel are important, and then be able to find the right set of match with the team. And furthermore, it doesn't hurt to use these attributes to better present yourself to potential employers, whether it be in your interviews or in the structuring of your resume. Including some of these key areas may help you to get that first interview that you are looking for. And finally, for educators, we do believe that some of the topics here are deserving of being included in your software engineering curriculum. Things like decision making, for which Herbert Simon won a Nobel Prize for, is an important area that we feel should be incorporated. And furthermore, in order to prepare students for the necessary attributes to work in a real-world environment, we feel that there are these attributes that may not be amenable to be taught in academic setting, things like being self-reliant. That is up to educators to better think about how they can better prepare their students for these attributes going forward. So hopefully, I've given you some insights into and give you some better reasons for learning more about what it takes to be a great software engineer.
All right. Thanks a lot, Paul. All of your questions are starting to roll in, so feel free to use that Q&A widget to submit your own question. I'm taking a look at a lot of them, and there are a lot of great ones, including some that have appeared a couple of times. So why don't we start with this one, Paul? A lot of people have been mentioning the software engineering body of knowledge. This is Thomas Hilburn from Carnegie Mellon. This is a huge collection of things that software engineers have to know. And there's some questions about whether or not it should include programming and whether or not it should include some of your discoveries. Do you think these are essential things that we should capture in what we train in software engineers?
I feel that that is absolutely correct, that the software engineering curriculum is, in fact, I think, a really great starting point. Because as many of the attributes that we saw, many of these engineers need to be able to get the basics right in order to even take that next step with many of these other attributes. So many of the core curriculum and the body of knowledge is particularly interesting. Now, one of the key things that about the technical areas that is particularly interesting is that many of the different areas focus on different sets of technologies, and even some products that were considered the end product were actually building technologies for other areas. For example, databases. For many, that's sort of the end thing they study for the people that were in the SQL organization. And for others, this was just a building block for some of the things that they worked on. For example, Dynamics, that build the customer relation management systems that build on top of databases. So being able to have lower level understanding and also a couple levels above it was kind of an important thing. And the key thing there is that really depending on the different product you're working on, the key technologies and the level of understanding you need are a little bit different. Now, I don't have a good understanding. I don't have a good, one-size-fit-all solution for what are the exact sets of things to look at, which is why one of the things we emphasized was that this ability to learn was seen as critical. And that is where the area where those sort of process-oriented things are what I see as kind of the important things that the software engineering body of knowledge, beyond that, those kinds of things a school can better incorporate. Things like decision sciences, like Herbert Simon, naturalistic decision-making, robust decisions, all those things that have been studying the other areas that are key process areas are important to incorporate. And then also more of the ability to learn. How do you go about learning? Like how do you grow your expertise, deliver practice, and all those other things that, in addition to single technical attributes, are the things that I think should be sort of additions to the software engineering curriculum.
Great, thanks, Paul. We also have a lot of questions that might follow up from that one, and that is, how do you think that this should extend into things like certification and licensure? There are a lot of countries that actually require certifications for software engineers. Are there aspects of software engineering personality or behavior or decision-making that you think should be part of licensing?
I think that's a great question, and I'll be perfectly honest. I don't have a very clear perspective on that. I mean, for one thing, I do see there are lots of these underlying technical areas. For example, the ACM curriculum that I see are pretty foundational. That if you want to be a software engineer, you really should have some understanding of all of them. And yet, in order to be a great software engineer, there are a great deal of things by working on Microsoft and other areas that I feel can only be learned on the job. And specific technologies, or even sort of the culture of an individual particular place. And to be able to say that having a specific set of things that works in all environments, I don't know if that is necessarily true. But what I do feel like a step forward, maybe something closer to the particular approach that's taken in modern day medicine, where, yes, there is a basic set of knowledge that you particularly need, but then there's an extensive lead-up and certification process towards actual on-hand experience, that you actually work in your intended particular technical area, that through seeing real-world situations, that through acquiring knowledge and accreditation in the actual particular environment, doing actual particular area of work, whether, and it's very different when you're talking about like working in the kernel level code versus SQL versus CRM versus online search, that you need to be able to have some of those specialized knowledge and special experience in those areas in order to be qualified as an expert for doing that area of software engineering.
Another interesting follow-up from this is some questions that some of you are asking about. What's the difference between a good software engineer and a good computer scientist? Do you think that this reveals some differences between those two types of titles?
Yes, I do. And if you actually look at the ACM curriculum, they do actually differentiate between curriculums in between software science, software engineering, and then there's there's several other ones. And one of the things that I feel is particularly poignant about it is about being able to handle things in the real world. That real world engineering has many of these complexities and non-ideal situations and vagaries that sometimes do not exist in sort of an academic or pure computer science situation. So if you look at, for example, some of the attributes in the engineering code, things like making informed trade-offs. And this is really understanding your context, right? Being able to say, you know what, in order to get our next level round of funding, in order for us to go out to product on time so we can actually make money, we need to trade off in these technical areas, right? And being able to in long-term anticipate needs about what is the trade-off being issued immediate hotfix because we're losing market share and customers are calling in versus having a bad patch that incur engineering debt. There's often no right or wrong decisions. There's no black and white, as there may often be in sort of pure computer science research. But in real engineering, you have to take those sort of considerations into consideration in making some of your decisions.
Great. Let's take a little turn and pivot to some more practical questions about some of the engineers out there who might want to improve their skills. One question I'm seeing a lot of is, when somebody's interviewing, how can they best convey that they have some of these skills? Are there ways for people to also interview to check for some of these skills?
So, so the particular process that I've since encouraged and I think is very reasonable to interview for is first go through and identify which one of these attributes is particularly important to you as an organization. Now, I'll be perfectly honest. Some of these things are less important in specific contexts and more important for others. For example, one of the persons that works in online says that you need to be much more being able to iterate much faster, much more curious, much more being able to take those risks, because in online situations you are able to revert your code immediately if you experiment with something that doesn't work out. So that the ability to sort of have that forward thinking was more important. Whereas there are some people that worked very down their line code in things like the kernel areas. It's you need to really think out through what's going on. If you try to make things and get something wrong, it can bring down the entire system and it can set everybody back only a great number of weeks, just because if you get something wrong, it cascades in lots of areas. So definitely the areas that are emphasized tends to be different. And then just going forward, going about assessing each one of these things, I'll be perfectly honest, if that's one of the areas I really do feel like researchers can better, provide looks into, that there is no necessary marshmallow test for some of these particular personality traits. Now, simply asking about these is a great starting point. When was the last time you exhibited this particular behavior? Or asking about what those behaviors mean to them, so you can understand how they view that area. And then one of the other good ways of going about doing this is actually structuring your hiring practices away from maybe just one-day interviews. Because let's be honest, for many of these things, to be able to figure out these things out in one day is simply impractical. That other approaches, like a more internship-based approach, where you're able to bring the young potential software engineer in and really observe how they handle real-world situations, and then being able to see how they're able to demonstrate those particular attributes over time may be a better approach sometimes than current practices allow. Now, in terms of for young engineers, so I'll be first and honest, not everybody's going to go and read this. But so if you read this and you sort of cast the way that you answer your question using some of these bigger terms can really speak well to kind of things that you think are important and you think things that they like. For example, one of the common things that we commonly ask people is about hey, tell us about this experience you have on your resume, right? What did you work on here? But in the process of telling those particular stories, you can sort of just embellish it. You can tell a little bit about how that particular project or that particular experience demonstrated your attributes in this area. It's hey, look, this was a particular result, but I was curious. So I actually dug into this area a little bit deeper, and I was really passionate about it. That I stayed over, a couple of months. I worked for 50 hours. That I really sort of able to come up with this really elegant design, and that was, that the software company is really still evolving now. That is really flexible. So really incorporating how you tell those particular stories and how you answer those particular questions can be an effective way of getting hired.
Great. On the same subject of interviews, another one of the common questions that all of you are asking is, what's your opinion about the way that companies interview now? In particular, a lot of companies do coding tests or whiteboard coding tests. Google had reported some evidence a few years ago that that wasn't particularly predictive of success within their organization. How do you think your results change our perspectives on programming in an interview?
So the particular perspective I have on this is that I think the happy medium lies somewhere in between. That you really do need some basic questions in order to pass a min bar, whether these people are able to pay attention to coding details. And there are some basic questions within any particular, I feel, that you need to see that they understand that particular concept. And then beyond those things and those areas, and as I was talking about before, and some of those other sort of coding, if you just focus on the coding questions, I think that is a little bit overkill. That you really need to sort of put them into sort of asking how they have, through their particular past history, demonstrated some of these other attributes, software attributes that they're dealing with. And then, as I mentioned before, one-day interviews really, I really do feel like they are more often they're more sort of hit and miss. And so, if you are able to sort of have an interview process that goes beyond a single day, assessing one is probably more effective. And just on the topic of, more on the specific coding questions. So coding questions is obviously one particular area where it's a very structured type of format where you're looking for the right or wrong answer. And I really do feel like beyond simple coding, there are other somewhat structured ways of asking some of these questions that can really help you understand whether this person will be good or not. And one of the questions I always like to use is a particular question that you can drill in subsequently deeper, and so that you can then sort of see how far they can go into the details, whether they understand the complexity, understand the underlying concepts in a very deep way. And the other way I like to do it is that I like to ask questions that have obvious trade-offs, that there are multiple techniques and approaches that can be used, and then to ask the person how they made that particular decision, that what are the plus or minuses. And in that particular way, you can tell a little bit better about their decision-making and their thinking process, and also just about, in addition to just their technical expertise.
All right. I'm going to pivot a little bit to some of the research dimensions of some of the work that you've done here. A lot of people are asking about generalizability, and here they're wondering about things like what do you think would be different in other organizational cultures other than Microsoft? Or what do you think would be different for software systems of different sizes? For example, a lot of Microsoft products are fairly large and have robust and massive code bases. What about smaller companies, startups, other things? So how do you think this varies by context?
So one of the things I want to mention about sort of the Microsoft context that I mentioned before is that, in fact, these teams do vary a lot in terms of their context. Many of them actually mirror quick startup teams. I mean, there's some people that are making games that go out rather quickly. That, some of these code bases are big, but others are, very small and confined and are very much like a lot of other software engineering process organizations. But in fact, this actually covers a great deal of different software engineering focused contexts, right? So, I mean, Bing is very much like Google in terms of how they operate and the domain that they look at, and even some of the processes they use. The one particular thing that I will say that came up that is in particular unknown, that it's maybe another important area to look at, is areas of software where the particular product is not software-centric, and where the organization is not a software development organization per se. And what I mean by that was many people mentioned places like finance, right? So this is some investment banking or other places in New York that many people have mentioned that their colleagues went to. For those organizations where software is not the essential product, they're viewed very much differently, right? So they're effectively a cost center. And how those organizations view software engineering, I think, is a much more interesting twists and context than maybe software engineering organizations alone, because I do feel like the range of Microsoft products and their technologies do cover that pretty well. But when you're getting out to the sort of where the software is may not be the central tendency, a lot of things come up, like like the fact that if you are like sort of craving to desire new things and you want to try new things, those may not be ideal in those environments because they're looking for stability and whatnot. And so so it's more about, I feel, that the central focus of the organization that may be an interesting organizational pivot rather than the specific areas within or software-centric organizations.
So given some of those contextual differences and some of those variations, what do you think are some of the next follow-up research questions that should be done from this work? Or perhaps you can talk about some of the follow-ups you've already done.
So that's a really great question. So obviously one of the things that you see here is that even though the way that we picked out the ones that are important to talk about are from how we heard informants talk about them. And although this is great, that we really want to have the more qualitative understanding, that we want to have a very larger sample that we can have some counts and ratings. And so this is actually part of the follow-up work that we've already completed, that we actually went out and surveyed further like 1,600 informants at Microsoft, almost I think a large percentage of the actual engineers that actually work, and looked at how these attributes rank relative to each other, and also, to some previous point, the influence of different contextual factors. In addition to that particular perspective of looking at software engineers more deeply, one of the things that I think we need to recognize today is that software engineering is a collective process involving experts who are non-engineers, right? So these may be the marketers, these may be the user researchers, the design folks, the artists that often work together. And I know software engineers, we as a community of practice have very particular views and particular perspectives on many of these attributes. Things like well-mannered, may or may not be viewed as strongly, by people in our community. But certainly when we go out to other communities, we have to go and talk to, our product planners, to our technical writers. What attributes do they feel are important for us to have and for us to focus on, so that we collectively as a team are able to produce software engineering outcomes? And that, I feel, is an important and necessary next step for us to look at.
One follow-up from that, from the audience is, do you have plans, or do you know others who have plans to study other organizations other than Microsoft? And what are some of the opportunities and challenges in doing that?
So one of the things I really do feel like this is a interesting thing to be looking at other organizations. We would love to see other people try to replicate our work. One of the things that we do have is that we have like 15. We do have a good number of these experts that we interviewed that went ahead and wanted to go ahead and share their interviews with everyone. So we'll be posting those up soon in our research area, that so that you can read these, understand more deeply, maybe develop your own understanding, and then such that when you go and conduct your research in your own organization or other organizations, that you can have a good compare and contrast between these things that happen.
Great. I think everybody is looking forward to some of that follow-up work. Hopefully others in the community are doing it as well. One of the things, going back to engineers and how they improve their skills, one of the more common questions from the audience is what do you do about developers that maybe aren't great or have problematic personality traits that you want to change? For example, if you were a manager and you had an engineer that had a particularly strong and undeserved ego, what are some of the things that you would be able to do about that, or how would you potentially have a manager shape that developer's behavior into something that was more aligned with some of your results?
That is a great question. And I'll be perfectly honest with you guys, that I've tried asking that to some of our experts, leads, these managers, and the ideas varied greatly. Some people, for some of the attributes, just didn't think that it was amenable, that it was impractical to sort of try to teach somebody some of these personality traits. That if you simply had a person that's like that, then sometimes they may not just be a good fit with the organization, that they need to move on. So that is certainly one possibility. Now, for some of the other attributes, many people mentioned that they felt like they couldn't necessarily be taught. And one of the things is about the Pavlovian idea that you sort of reward good practice and good outcomes, and then you sort of discourage bad sort of behaviors. Another thing that people also mention is about you as a sort of leader of an organization exhibiting those things yourself, that you lead by example. You walk the walk, and then you tell other people, like, hey, look, this is what you need to do and how you need to do it. That through over time, they see that that is sort of the mode that this organization operates, as exemplified by their leadership and by other engineers. That most people catch on. That people are social animals in general. That they recognize these approach going forward.
There's a related follow-up question from that, and that is that a lot of engineers might look at some of these attributes and not see them in themselves. And some people are asking in particular about being introverted. Many of the attributes that you've mentioned in this talk really do require some skills in being able to talk to other engineers and be open to conversations and work extensively in social environments. What do you do with an engineer who maybe isn't as comfortable in completely open social spaces 24/7 with a team?
Yeah. So one of the things that this is not unique, obviously, to the people on the line. Many Microsoft engineers also mentioned that it's often weird for them, where they have grown up effectively being taught about how to code and how to effectively design things, how to work well. But when they eventually reach that level of expertise, that all of a sudden they're being pushed into roles as leads or managers, that they have to deal with a whole entire set of attributes they've not learned before. And this really underlies one of our key things that we've mentioned, that we've discussed before, is that these are some of these things you just have to, it just takes practice, right? I mean, you may not be good at it because you've never had a chance to practice it in the past. Now, there are trainings available that can teach you to be better in some of these particular areas, but it really does take you to be open-minded. It does take you to want to continuously improve in these areas, to have a desire to want to improve. I mean, I really do feel like there are things like just giving presentations. You just have to understand the concepts and then do it a bunch of times in order to achieve it correctly. So I do see there are certain specific playbooks and there's certain specific approaches that if you just follow those particular approaches and the particular process that I laid out, that can be pretty effective, even if it doesn't take you to being magical into interpersonal communications, but at least enable you to become a person for which that is not an inhibitor to your future growth.
All right, thanks a lot, Paul. I'm afraid that we've run out of time for today. I do want to thank Paul Lee again for his informative presentation and the insightful answers to the many questions that all of you have had. I want to thank everybody that attended for all of their wonderful questions and their engagement and their time. And a special thanks to ACM for hosting and sponsoring this webinar. And finally, a thank you to the National Science Foundation for funding my time and Paul's time to do this research and disseminate it to you. And with that, we're going to wrap up. Thank you.